Swayam Prabha. Digital India. Educated India.
So today's topic is data summarization. Now, when I want to summarize the data, then this data can be summarized in two ways. One is the average, and the other one is the variability part within the data. Now, the average can be of four different types. One is simple average, which we call arithmetic mean, and almost most of you are familiar with the arithmetic mean. The next one is weighted mean. Then comes geometric mean, and the last one is harmonic mean. So the data can be characterized in terms of what is arithmetic mean, or weighted mean, or geometric mean, or harmonic mean, depending upon the nature of the data. The other part, which is the scattered part of the data, that is the variability aspect of the data, that can be also quantified, or you can say characterized, by four different ways. The first one is range. Then the next one is mean deviations. Then comes standard deviations, and the other characterization term is coefficient of variations. So when we have a group of data with us, we can find out what is the average value of it. That is one of the statistics in which we will be interested. The other part is what is the variability content in it. So these two aspects are very, very important in order to characterize a group of data. We are going to now discuss these aspects one by one. The first thing is the arithmetic mean, and this one is very, very simple, that if we have a set of observations or data like x1, x2, x3, xn, there may be the values of some variable x. X could be the height of students in a class, or it could be the weight of students in a class, or it could be length of fibers. It could be any variable. Then the simple average can be stated as given by the formula, that is x bar is x1 plus x2 up to xn, where n is the number of data points divided by n. So it is sigma xi divided by n. So this is a very, very simple how to find out the arithmetic mean. In this calculation, actually, one important point is that all observations get equal importance. That is, what are the observations? Some values are small or some values are big. It does not matter. In this calculations, each and every value of the data is equally important. They get equal importance. Now, if we say that these are the marks obtained by a student in quiz test 1 and 2, assignments and written test, then viva examinations. So these are the individual marks in a particular course that a teacher is teaching. and his average score therefore would be sum of these individual score divided by 5. That is the average score he has. The total score is the sum of all these values. These are the individual score, the numerator part. The total score will be sum of all of them. If I want to know the average score, then I have to take the summation and divide it by 5, because there are 5 different ways the teacher wanted to evaluate the person. So that is how we can find out what is the average mark that he has obtained. Next is the weighted mean. What is weighted mean? Now, at times there is a need to give unequal importance to different member of the data set. And in that case, the arithmetic mean is not a good indicator of the average, because depending upon the nature, the importance given to different aspects would be different. I will come to an example that almost it is this previous example, as a teacher gives different weightage to the various types of tests. That is, whatever test marks, what are the marks which are obtained in different types of tests, the teacher may decide that the weightage to be given are not exactly same, or the importance to be given for quiz 1, quiz 2, vivacy or written examination should not be same. In that case, the weightage can be given to different types of evaluation, and then we can find out what is the average score. So if x1, x2, x3, xn are the score, and the weightage given are w1, w2, w3, wn, then the weighted average, which is x bar w, the subscript w indicates that is weighted average. We can say weighted mean or weighted average, basically meaning same thing. This will be w1 into x1 plus w2 into x2. It will continue up to wn into xn divided by the sum of the weightage. So it is sigma wixi divided by sigma wi. This is another way to find out the mean, where we have to, there is a need to give different level of importance to the scores. We can give an example now. Here again, let us say that same data we are taking, the score for quiz 1, quiz 2, assignment, variables examinations are all stated here, and the total is 68. The weightage that has been decided by the evaluator is 0.05 for quiz 1. 0.05 means basically 5% weightage. Quiz 2, 0.05, assignment 0.2. Like that, if these are the weightage, the sum of the weightage is 1. And therefore, if we try to find out what is the weighted average of score, then we have to multiply the actual score with the weight. So 14 into 0.05, this is 0.7, 12 into 0.05, 0.6, like that. We'll keep on multiplying them and put the product in the third or in the fourth column in this case. And if we then sum them together, we get a figure 14.1, and that 14.1, when you divide by the sum of the weights, which is 1, we get a figure 14.1 in this case, and that becomes the weighted average. So this is how many a times we need to calculate the weighted average. So simple average was 13.6, the weighted average is 14.1 for this particular example. Another example which we will come across is mixing of fibers. So many a times the fibers are mixed together for different technical reasons, or could be because of cost reasons. We mix fibers of different varieties, sometimes fibers coming from two fibers to two different chemical nature, so they can be mixed, like polyester can be mixed with cotton, so they are chemically different. Sometimes cotton can be mixed with cotton also, because we may want to mix coarse cotton with fine cotton in order to bring down the cost of the final yarn. That is what is practiced in the industry. So fiber mixing. Suppose say that three types of fibers are to be mixed and their average lengths are L1, L2, L3. And the weight that we are taking are W1, W2, W3. That is W1 kg of L1, W2 kg of L2, W3 kg of L3. These are what is chosen now. So total weight of fibers is going to be W1 plus W2 plus W3, which is capital W, and then the weight proportions of the component is going to be P1, which is W1 by capital W, P2 is W2 by capital W, and P3 is W3 by capital W. So the mass base average, this is the we are going to calculate. So now the proportion has become P1, P2 and P3 for these three different categories of fibers, where the fibers are classified according to length. Therefore, the mean length of this mixture is going to be P1 L1, P2 L2 plus P3 L3. This is going to be the mean length of the fibers. So this is called weight biased average calculations. So there is a, now we are giving some kind of weightage to the fibers of average length L1, L2, L3. They are not getting equal weightage. So, and this weightage is based on their proportion in the mixture, which is W1 by capital W, W2 by capital W, and W3 by capital W. So this is how we try to calculate the average length of fiber in a mix. Now comes another type of mean that we calculate also in textile. It is called harmonic mean. Harmonic mean is, by definition, it is the reciprocal of arithmetic mean or reciprocal of the observations. Arithmetic mean of reciprocals of the observations. So harmonic mean is the reciprocal of arithmetic mean of reciprocals of observations. So let us say x1, x2, x3 up to xn are the values of n different observations. So they can be, suppose, fineness of fibers. And in that case, the harmonic mean will be 1 divided by 1 upon n, 1 by x1 plus 1 upon x2 plus 1 upon x3 up to 1 upon xn. That is, these are the reciprocals of the observation. 1 upon x1 is the reciprocal observation. So we are summing them up. 1 upon x1 plus 1 upon x2 plus 1 upon x3, we are, all the reciprocals are added together and we are trying to find out the average. So we divided by 1 upon divided by n. So this is the arithmetic mean of the reciprocals is the denominator. Now reciprocal of that is the harmonic mean. Therefore, 1 is coming on the numerator and the entire arithmetic mean of reciprocal is coming at the denominator. This is how we calculate the arithmetic mean, and this is, if we try to simplify, we take n in the numerator, so n goes there. It is the sum of the reciprocals of the observation x1, x2, x3 up to xn, and we write it like this: small n by sigma 1 upon xi. If the data is grouped means there is a frequency, that the frequencies of this data x1, x2, x3 is f1, f2, f3, fn. There may be situations where we will have group data. In that case, this is how we calculate the harmonic mean. What is there? You see in the same equations what is coming is fi. So fi, f1, f2, f3, these are the individual frequencies of x1, x2, x3. So we take this average, f1 by x1, f2 by x2, f3 by x3, fn by xn. And this formula therefore gives us the harmonic mean of the average values. For the group data, this xi's, that is this xi, could be the midpoints of the group. Suppose we have let us say we have groups like this, L1 and L2, one group. Another group may be L3, L4. So these are the L5, L6. Now the midpoints of these groups are x1, this one is x2, this group is x3, like that it goes on. So if it is a group, it has a lower boundary and it has upper boundary, or lower limit and upper limit. And midpoints are the middle point of that lower and upper values. There x1, x2, xn. So in the harmonic mean, it gives less weightage to larger values and more weightage to the smaller values. How? Now, if the value x1 suppose is too small, then 1 upon x1 is going to be very large. So, whereas if xn or maybe x3, some data may be very large, because you are taking reciprocal is going to be very small. So there could be situations where we need to give more importance to the lower values than the larger values. And we'll take an example and I'll show you how it is or where it is important. HM, that is called harmonic mean, is useful in averaging rates and ratios. It is most appropriate average when the unit of observations are per day or per hour or per unit per worker, something like this. Then harmonic means are used to find out the real average value. Simple mean will not be able to give the what is the average, proper average. Like now weighted harmonic mean is also there. So weighted harmonic mean is computed by taking into account the relative importance of different observations. And let us say there are n observations, x1, x2, x3 up to xn, and the weights are w1, w2, w3 up to wn. The average can be calculated by giving importance to the marks scored. If this is these are the marks, then it is the same type of formula, w1 plus w2 plus actually to be w3 up to wn divided by w1 by x1, w2 by x2, wn by xn. This is how we can find out what is the weighted harmonic mean. How and where it is to be used? That example is coming now. Suppose a mill buys cotton at the rate of 200 per kg, and 220 per kg and 230 per kg in different seasons. This money spent in 3 different seasons are 10,000, 33,000 and 26,450. What is the average price paid for the cotton? Average price paid for the cotton. How much price was average price paid for the cotton? So the 3 different seasons the cotton was purchased. So rates are different, and now time these money spent are also stated here. So what is the average cost of cotton? Solution will be, this is how we should go. This formula which has been stated here, this money spent represents the WI. So we have in this case W1, W2 and W3. Only 3 readings are there. So we'll find out what is the sum of WI, this value. 10,000, 33,000, 26,450. That means total money spent was 69,450 rupees. Then comes the quantities bought. How much quantity was bought? For the cotton which was 200 per kg, the quantity was 10,000 by 200. The next was 33,000 by 220. And for the third, it was 26,450 by 230. That means 50 kg, 150 kg, and 115 kg. This much cotton was bought. So cotton of which was bought in season 1, 50 kilo, next season 150 kilo, and third season 115 kilo. So total is 315 kg. So this much cotton was total bought. And this is the total money that was spent, and therefore logically we can also say that what is the total price that we pay and what was the total quantity of cotton we purchased. So total cost and the total kg purchase, the ratio is give you the mean value, and that is what is harmonic mean. Because you see here the numerator is basically the total money that was spent, and the denominator in this formula is representing the kg of cotton which was bought, weight of cotton cost. So this is the cost part and this is the weight. So this formula, if we directly use, we get this figure 221.07, which is the average value. It is not the average of 200 plus 220 plus 230 by 3. So basically it is the total amount spent divided by total kg of cotton that was purchased, that ratio is really justified and logical to find out the average price of cotton. So that becomes in a way our harmonic mean of the price of cotton. It is not the simple average. Another another calculation is harmonic mean based on weight percentage is like average fineness of a mixture of fibers cannot be their simple arithmetic mean. Since number of fibers in a given blend component depends upon its own fineness and weight. It should be based on weight divided by the total length, and that is what is basically harmonic mean. So if we, that means the same formula will be applicable here also in this case as well. That is harmonic mean is total weight of fibers by total length. That basically means W1 plus W2 up to Wn divided by W1 by X1, W2 by X2, Wn by Xn. And if this formula now, where W1, W2, these are the actual quantity bought. Now if I divide it by the total weight, W, the numerator and the denominator both, then W1 by W, W2 by W, Wn by capital W. Here also I divide by W. All the whatever is there in the numerator and whatever is there in the denominator, all of them are divided by capital W, which is the total weight. Now, what is W1 by W? This is basically the proportion of that fiber. P1 is W1 by capital W. So W1 by capital W actually represents the proportion of fiber of category 1. P2 is similarly proportion of fiber of category 2. So this becomes in a way sigma Pi by sigma Pi by Xi, where Pi is the weight percentage. It could be proportion, or if we multiply it by 100, we can express it in terms of percentage also. And in the example with two fibers, suppose cotton A and B have a fineness of 3 microgram per inch and 5 microgram per inch are to be mixed. The mixture ratio, let us say 30-70, 40-60, 50-50. What are the mean fineness of the mixes? When the mixture ratio is 30:70, that basically means I have 30% of 3 microgram per inch fiber and 70% 5 microgram per inch by fiber. So we can use this formula and replace P1 and P2 by 30 and 70. Or if I want by proportion, we write it 0.3 and 0.7. If I express by percentage, then P becomes 30, P1 and P2 becomes 70. So 30 plus 70 divided by 30 plus 3, 70 by 5. So this becomes 100 by 10 plus 14, and you get a average value 4.16. It is not the simple average. Simple average is how much? Will be 3 plus 5 by 2, that is 4. But actually this should be this 4.16, not 4. If the mixture ratio is changed, then this value become, if it is 40 is to 60, that is proportion of fine fiber has increased from 30 to 40, and coarse fiber it has decreased. So you'd expect the mixture fineness to be on the lower side, and you see the value is coming 3.95. And when I go for 50-50, then the value is coming how much? Is coming 3.76. So the simple average is this, but actual averages will be the harmonic mean between these two, and they are not going to really match. So in situation like this, we cannot use arithmetic mean to find out the average. We have to go for harmonic mean. And in this particular example, this harmonic mean, basically, to quickly remember what is harmonic mean indicates or how to find it out, basically total weight divided by total length. If the finer variety fiber is more, length of those fiber total is going to be more. So basically, because the fineness definition is weight per unit length. So when we try to mix two different fibers of different fineness and whatever is the weight we choose, to find out the actual fineness of the mixture, what we need to do, we have to find out what is the total length of fibers in that mix and what is the total weight, and we take the ratio of these two. That is what is basically harmonic mean. If I go by the formula, this is, and you see, the every time the numerator part is actually indicating the total quantity that you are taking, is basically reflecting the weight, 30 and 70, 30 kg or 70 kg, or 40 kg and 60 kg. And the lower part, denominator part, is indicating the length. This is reflecting basically length. So it is basically, ultimately, it is weight by length ratio, and hence that is what is going to give you the actual value of fineness. And in such situations, we have to use harmonic mean. If equal weights are taken, then, like in the case, total weight of fiber the total length, if all the weights are same, W plus W plus W, or W1, 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 so it is basically NW, and in that case the formula becomes N divided by 1 upon X1 upon X2 as 1 upon Xn. Now we go to geometric mean. This is used when we need to measure the rate of change of variable over time. Geometric mean is the nth root of products of n values. So by definition, this is what is geometric mean, and this is useful for averaging ratios, percentages, and rate of change in one period over the other. In such situations, we use geometric mean. We will take an example also. So mathematically, if we try to express what is geometric mean, the geometric mean x bar g is the nth root of x1 into x2 into x3 up to xn. This is what is geometric mean. For simplifying the calculation or purpose, when you try to evaluate a value, finding out nth root is very difficult. If we go for 5 observations or 10 observations, that becomes very difficult. So the simple way is to take log. So if you take log, log of xg equal to log of x1, log of x2, log of xn divided by n, and it becomes sigma log xi by n, and therefore x bar g becomes anti-log sigma log xi by n. That is how we can quickly calculate uh, and find out what is the geometric mean. Now, if we take an example of this, let us say the percentage increase in price of cotton is 5% in 2020, 10% in 2021, and 6% in 2022. So these are the percentage increase in cotton price. So what is the average increase in price? A simple average would mean 5 plus 10 plus 6 by 3, which is 7%. But this is wrong. This is not the correct way of find out the average. What we should do, the correct average is basically this. Geometric mean is this. It's a cube root of 5 into 10 into 6, and that is cube root of 300. Finding out this is really difficult, but if you have a calculator or a computer, you can find it out easily. Otherwise, we have to go for log to find out what is the geometric mean. And you see, this value is different from this value. So this is the average, it is the simple, and this is the geometric mean. So they are not really same, and finding out average by taking simple, finding out a simple average is not the correct answer. So after discussing the mean, the next important thing is discussing about the what is the median. So this is also something which is important for us to know. What is the median value? So median is the middlemost value in the area of a set of observations. Let there be n observations. If n is odd, the median is n plus 1 by 12th observations in the array. So we have to first, the data set is there, we have to first make an array, either in increasing order or decreasing order. That is the first step. Second step is then we have to find out how many observations are there. If it is n, then we have to find out that what is n plus 1 by 2 if it is odd. Suppose we'll come to some examples. If it is even value, that we have 50 observations, then 50 is even number. If we have 51 observations, then 51 is a odd number. So depending upon odd or even, we have to find out, in the case of odd, median is n plus 1 by 2 12th observations in that array. Median will divide the data into two equal halves. So 50% of the data will be above this and 50% of the data will be below this. So many a time the student will ask, what is the median marks in a test? If there are, so the median marks will indicate that 50% of the students are above that mark and 50% students are below that marks. So median therefore will divide the data into two equal halves, one half smaller than median and the other greater than the median. Median is not affected by the presence of unequal or open-ended class interval. So class interval sometimes may remain open-ended, but median value normally is not getting affected by this. Unlike mean, the median is least affected by extreme values of data. The extreme values of data will not be able to affect median much, because you are, first of all, you are trying to put the data in an increasing or decreasing order. So extreme values will be going either at the beginning they'll stay, or they'll stay in the end. So the values in the end or the beginning is not going to affect what is there in the middle. So therefore, extreme values will not be affected, will not be able to affect the median value. So let us say the marks obtained by student is shown here, and the table is given here. Marks are 20, there are 8 students. So this is a data where there is a frequency also. So 20 marks were obtained by 8 students, 30 marks was obtained by 12 students, 40 marks was obtained by 20 students, 60 marks by 6, 70 marks by 4 students. So this is the data that we have, and we are interested to find out what is the median value. First, we will find out what is the cumulative frequency. So 8, and 8 plus 12, 20, 20 plus 20, 40, 40 plus 10, 50, 50 plus 6, 56, 56 plus 4, 60. So these are the cumulative frequency. And then what we will find out, what is Fi and Xi, that if I multiply these two, what are, this is the way to calculate the median value in the case of data where frequency exists. So how to find out the mean value of this? Mean is simply, in this case, sigma Fi Xi by sigma Fi, or F indicates the frequency. So what is Fi Xi? Summation is 2460, we write 2460 here. And what is the total number of students frequency? Fi is 60. So 2460 by 60 is 41. 41 becomes the average marks obtained by the students in this course. So mean is 41. Then comes the median. Now median is going to be 60 plus 1 by 2, 30.5 observations. 30.5 observations, if we try to find out, how to find it out? Because 30.5 observation is somewhere here. So up to here it is 20. Then 30 is coming in between these two. So what is we'll do, that the 30.5 observation against Xi is going to be this marks 40. This is not here in this band, it is going to be above this, and therefore we'll say in this case 40 is going to be my median value. We will take another example where we have group data. In because group data, it is a little bit more complex, because the data is grouped and also we have frequency. So in that case, the median class is the one whose corresponding cumulative frequency covers sigma Fi by 2 or sigma Fi plus 1 by 2, where sigma Fi is the even number or sigma Fi is the odd number. Depending upon that, we have to find out What is the value of sigma fi by 2, or what is the value of sigma fi plus 1 by 2? And we have to then find out the median using this equation. The median value is going to be L1. L1 is the lower limit of median class, plus CF is the cumulative frequency up to the class immediately preceding the median class. Cm is the width of the median class. Fm is the class frequency. Now it will be clear if we go to the example, numerical example, it will be easy. I think comprehension will be little easier. Now here is the data. So we have class interval lower and upper limits 1050, 1059, 1060, 1069, and these are the class frequencies 6, 9, 15. That means the number of data within this group is 6, number of data in this group is 9. Like that, the group or the classes are shown here, and the corresponding frequency is also drawn here. And here we show the cumulative frequencies. Now, if we use this formula, first we have to find out what is the total number of total frequency. So I have to add all of them, and this figure will be 80. So that is what is 80 is. Now the solution will start like this. We have to find out what is Fi by 2. Is 80 by 2, that is 40, that is an even number. And where Fi by 2 is contained, this 40 is here. It is not here, it is not crossing this. So this is the place where this Fi by 2 40 is contained in this cumulative frequency Fc, which is equal to 55. So it is somewhere here. It is not there, it is not here. Now, what is the class interval in this case? So corresponding to this, the class interval is 1080 and 1089. So that becomes my median class interval. This median class interval will be this 1080-1089. That means the value lies here. What is the exact value? For that we have to make use of these equations. Now in this, once we identify the class interval in which it lies, after that we have to make use of these equations to find out MD. So in this equation, what is L1? L1 is the lower limit. So what is the lower limit of the median class? 1080. So we write 1080. L1 is equal to 1080. Then what is the cumulative frequency of the class immediately preceding the median class? That is what CF is. So CF is basically in this case this. This is our CF 30. That's the previous one, that is the 30. Next, the width of the median class. What is the width of the median class? 80 to 90. So there are actually 10 will be the width. Difference between these two, plus 1. Then frequency of the median class is how much? Frequency is 25. So Fm I write 25. And now for these equations, we write all these values we have already found out from the table, and then we plot, we just substitute the values and we get a figure 1084. So 1084 becomes the median value in this present case, where we have group data with frequencies. If the data is not grouped, if we have n number of data simply, then it is much easier to find out. But when the group data is grouped, and also there are class frequencies, then this formula basically we have to use. This is how we have to find out the median. So there could be situations where we have to find out the median value. Maybe it could be related to suppose salary of the persons working in a factory. So in the factory there are people of different categories, different levels, so they get different types of salary. They can say within group, on some group from this value to this value there are so many people, another group value there are so many people. So we can total whatever salary is obtained by the people in that factory, we can group them and find out how many people lie in different groups. And then if we're interested to know what is the median value, so that we can get an idea how many people are above this median. The median means already 50% people will be above and 50% will be below. So many times such kind of informations are required, and this is how we can calculate. So where the median lies, that gives an idea, depending upon what type of problem we are facing, that how many people are more or less than getting this value. So accordingly, policies that could be made. Relationship between mean, median, and mode. Now here three types of distributions are shown here. We have not yet discussed the distributions, which we'll discuss in some other lectures. In the coming lectures, we have more detailed discussion on different types of distributions. So here I am showing you, these are the, you can say, the type of distribution or the nature of the distribution of some variable which is shown here, and they are basically the graph showing as if they are continuous variable, that is the variable which can take all types of readings. That you will come to know that there are variables which can only take readings which take values which are only integers. So we call them discrete distributions or discontinuous distribution, we call them. But there are also variables which can take any value, there is no constraint on them, and in that case we say they are basically continuous distributions. So these graphs are basically of continuous distributions, and three typical natures are shown. One is a symmetric distributions, other one is positive skew, and the third one is negative skew. And in the case of symmetric distributions, the mean, median, and mode all are lying at the center. They will all perfectly match. Whatever is the mean value, the same will be median value, and third, same will be mode. Mode, what is mode? Mode is a value with highest frequency. That is called mode. We have not really discussed what is mode, but mode means the value with highest frequency is called mode. Now here, wherever peak is, that means peak indicates the frequency in this case. So this value here is having, the peak is here, so we can say this value of the variable is basically the mode. Because it is symmetric, the median also will lie, because this part and this area is actually exactly same. So area indicates in this case the proportion of the values lying on the right hand side or left hand side of this vertical line that indicates the middle. So in this case, mean, median, mode all will be same. But if the distribution is positively skewed, like there's a long tail going on the right hand side, or negatively skewed, where the long tail is going towards the left hand side, then we see the location of mode, median, and mean. See, locating of mode is whatever the frequency is maximum. Where the peak lies, that is mode. So mode is in this case here, in this case also here. But the median and the mean, if we look at it, the median is here and mean will be, the blue line indicates where the mean lies. So as the distribution becomes skewed, mean gets affected more than mode and median. So mean will shift more than median or mode.